Hey, hi everyone. This is Bharat. I've teamed up with Lou and Karthik for our project, which we dealt with classification of job trends and salary predictions based on the job description, which are posted on the uh, you know uh, uh, job seeker websites. The main project background was like the most important thing in the job search is to know where you are and where you stand, where you want to go next. So the mentality of the job seekers is much like an product manager. We think like a product manager saying that like these are the skills and where do I fit. Um, and so what the market is looking at and the skills which we possess, how can we map that? So I think everyone will try to become a smart product managers in that in that point of view. So I think this project will help you to map the recruiter skills like the company skills what they need and the skills which we possess. So we wanted to map each other, and we can predict the salaries what we can expect from the job seekers point of view. So that's the basic project background. So for this, we scraped around 1 million job descriptions from Indeed websites. So for that, we've written a piece of code which from where we scraped the data. um, uh, like we normally we scraped all the features whatever is available from the Indeed websites, and from there we did the we calculated the weightage of each feature, and from there we summarized to these few features what we have over here, which are like job type, company, degree requirement, major, industry, and years of experience, and miles from the metropolis, like which is from the city, and the salary. So I think salary will be the target variable over here for us, and the rest of them will be the independent, the rest of them will be the independent variables. So yep, these features which we which we have over here were extracted from the job description, and we just aligned by having the functions which are declined, sorry, which were declared in the scraper code. So yeah, that's the background of the data where we get it from, and on the project background. So this is our problem statement, which is the classification of job trends which are posted in the job market websites, just like Indeed and Glassdoor or any other job marketing websites. And we wanted to predict the salary based on the description what they have posted. So mostly, I think this kind of an application would be suitable for the people in HR for different companies, so that they can use this model in their application, and they try to predict the salary which they have to be compensate to the job seeker based on the current market trends and the location, of course. Yeah. So that's the problem statement what we have, and for that, what we have done is we have classified the data set um, into uh, um, into m- into multiple into multiple paths, and we try to do the exploratory data analysis in it. So the analysis is aimed at explaining each and every steps, like defining the problem and discovering the data sets, and finding out the features what we have, and then from then we develop the models, and whichever is the best model we wanted to deploy that into the production. So that's the overall workflow of this development. And as we mentioned, as I mentioned earlier, so those are the set of features which we selected based on the weightage of the scores, so what we have. And yeah, we did the exploratory data analysis, and we divided the training data and the testing data into 80 to 20% ratio. And these are the four models which we try to use to predict the salaries, which are random forest, linear regression, and gradient boosting, and XGBoost. So let's see how it goes. So as I mentioned, yep, data set we scrapped around 1 million, and out of it, like 5 jobs were having the salary empty. So we don't want to have the records in the data set. So we just took that off. The remaining data set would be like 1 million minus 5. So this is the classification where we are having these many number of rows and the company ID and job type, degree, industry, and major, years of experience and salary. Um, if we plot it, if you wanted to visualize the target variable, um, so we have used this box plot and the distribution plot to just to see how the target variable is distributed when compared to the normal curve. So I think the results which we can see in the graph is like which is very good. Like the mean and median were 116 and 114 respectively. And if we just see that yeah, like inter quartile ranges in the box plot, the black one over here, I think that indicates the target indicates the target variable. Um, Sorry, not indicates the noise, I think, which are just like an outliners. So I think we just need to get rid of this, and we need to find out like what are the features that were causing this noise in the data set. So for so yeah, we'll go through that, and we just wanted to see the upper bound salary and the lower bound salary, I mean the highest and the lowest salaries, and we just calculated the interquartile range, and we just defined a function which you can see in the bottom in order to measure the statistical dispersion. So yeah, we took the 75% so like 75% and 25% percentiles within a year, and then we calculated the IQR, and we plot over here. So the interquartile range is around 53. If you see the formulas which we have used, and see and formulas which are used for the IQR and in order to calculate the upper bound and the lower bound. So if you get the difference, I think uh, the upper and the lower bounds for suspected outliners in the box plot are 220 and 8.5. So I think 8.5 will be the lower, and 220.5 will be the upper bound in the salaries. So this is I think we can fix this as a baseline. So let's see what we get. So, and we also check that we check the values like what are the how many jobs were below the lower bound, which is 8.5, and how many were above the upper bound. So we haven't found any jobs which are less than 85K in the data set what we have. Um, and with the upper bound jobs which are more than 220K is these are the job titles for that, like CEO, CFO, and CTO, and etc. So I think these guys are getting paid more than 220. So, and we try to visualize the independent variable with the dependent variable, like to the target variable. And if you see the correlation between the company ID and salary over here, so we just try to plot these two features, and in a similar way uh, uh, we have done the summary of statistics. So it describes what it describes is like the standard deviation of the experience is 7.2, 28.8 for the miles from metropolis, and 38.7 for the salary. So I think these are the summary of the statistics for the numerical data what we get, and if you try to plot the correlation between the job type and the salary, and this is the kind of a visualization what we get, and I think CEO over here is getting the highest salary uh, when compared to other job types. Okay, and so this is the correlation we try to plot between the degree and the salary. And the doctoral degree were getting paid higher when compared to, of course, the high schools, bachelor's, and the master's degree people. And if you see the correlation between the industry and the salary, I think the oil industry is getting get getting more uh, getting paid more in their with the jobs when compared to other industries. So yeah, and finally, we try to plot the correlation between the experience and the salary. So as soon as the experience increases, the amount of salary gets increased. So we can see the positive correlation between experience and salary, as the plot suggests. Um, out analysis could further be, I mean, like analysis could further be aided by residual plot analysis of these variables. So. Uh, so what we can see is like we try to plot the other residual plot which shows the spread of these residuals, um, and we observed that the variance in the salary figures seems to increases slightly with the experience. So I think we need to figure out why this the variance is occurred between the I think this experience and the salary, and we try to plot the confusion matrix with this, and so we can see that experience is having a strongest correlation, so it's on the top, and with compared to the when compared to the salaries. And so earlier we have seen some outliners, so I think we need to find out why there is this kind of a noise has been seen. uh, and so I think those are because job ID and the company ID. So these IDs were not that good enough. So we thought of finally cleaning up the data by taking off the job ID and the company ID from the data set. So because if we take that off, I think the data set is pretty good and can be fit into the models what we thought. So yeah, so we just removed the company ID and the job ID, and so now I think the problem what we got is we just wanted to convert the categorical data into numerical data. So we just added this function called get dummies to the categorical data. So just it converts the from categorical data from categorical to the numerical data, and then yeah. So what we got over here is so the confusion matrix when having all the kind of the features what we have in the data set were plotted over here. So the highest correlation for the with the target variable is the experience, which is having the which is having a value around I think it's 0.03 or something. Yeah, but which I can't show you properly, but yeah, that's the value. And also we can see the strongest correlation with some of the values like uh, what I can see over here is the job roles. Sorry, the job roles like the CFO, CTO, and CEO are having the high correlation with the salary. So they were plotted over here. I mean, we can see that in the plot, and the plot also shows that doctoral degree is also highly correlated with salary. Uh, so we try to put the baseline in order to find which model is the best one. So as we discussed earlier, these are the four models which we try to implement and find out the best one. And we divided the data sets. We divided the data sets into 80 into 20 ratio. Uh, so these are the number of training samples, and these are the number of testing samples which you have. And so this is the first model which we try to develop, which is gradient boosting. Uh, so as this is just the brief introduction on gradient boosting, and so which is just like more typical to the decision trees. And so this is where we try to fit the model and make the predictions of it, and then whatever the predictions we have, we try to evaluate by using this calculating the mean square error. And the mean square error for gradient boosting is around 371.96. So I think which is a bit high, but we'll just compare with other models what we have. So, and the second one which we implemented is random forest. The random forests are like an ensemble learning method for classification and regression. And so, which when we try to fit the model, and we got an accuracy of 75.06%, which is not bad when compared to the gradient boosting. And these are the first five salaries which we try to predict with the data set which we haven't, which we passed to the test data, and uh, and we found the accuracy. No, the accuracy like what we saw is 75.06, and this is the mean square error which we have for the random forest model. And the third one is the linear regression model. And so this is the uh, and this is the code which we try to fit the training and the testing data. Um and we try to plot the intercept for the linear regression model, and where you can see the intercept is around like -13 so and so, which is in the negative form. So not to worry about that. And yeah, so if you try to predict the value of the training data for the salaries, so these are the values, the first few values which we try to predict the salaries for so and so job titles. And the accuracy uh, is around like 74.3, where we have used some five cross validation, like cross validation, and we tried to calculate the score, and we just found accuracy to be 74.3. And if we calculate the evaluate when we try to evaluate this model, and we got the evaluation score of 385.07 for this model, which is a bit higher when compared to the other two models. So I think if we plot the accurate value versus the predicted value, so it's almost like the mean is a bit more like around 100 120 something, and the predictor values would be like 130 and 140. So it's not much huge difference. So the accuracy is around 75%, which is not bad, but it's not that great when compared to the other two models, because the other two models were around 75%, 76%, 75 to 76%. So yeah, so this is the last model which we try to predict, which is XC So I know XC is getting more popular nowadays. It's one of the outgoing, like very well used machine learning algorithm, and mostly they were used in Kaggle competitions for structured or tabular data. And yep, we try to implement that in this in our model, and this is the when we try to fit, and so this is the code which we have used and function. And but we got the when we try to evaluate, we got the mean square error as 623.56, which is way high when compared to the other three models. So we can definitely conclude that this is not the best model to deploy in the production. So yeah, comparing all four models over here, so the mean square error is very low for the gradient boosting algorithm. So I think gradient boosting model will be the best one to deploy in the production, but with this data set. So I think this can be this model can be good for deploying it. So the approach what we try to solve over here is we try to clean the data. We try to clean the data set and see how the data is being distributed. We're using this exploratory data analysis and finding out everything. And we just used four machine learning algorithms what we have, and we try to do the cross validation and the best models, and cross validation find out the best model which is having the lower MSE score. So we found that gradient boosting is the lowest one, is the one which is having the lowest MSE score. So with that, we conclude that gradient boosting is the best one to deploy into the production. So uh, the main the main use of it and uniqueness in this project, I think we found that this can be developed as an application. and where the application is using the gradient boosting algorithm in the backend in order to predict the salaries based on the data, whatever we pass. So and the location and the other features like experience and everything. So with this, I think the HR department of any other company, if they are using this kind of an application, uh, they can easily budget themselves, saying that okay, so and so person can be compensated with this much of salary with these skills, with this kind of an experience, with this number of years of experience, with respect to the current job market trends. So I think this is this is the uniqueness in our project, which we thought, and we try to use it. So yeah, so finally, so that's what we have done, and this is the citation which we used, and these are the references, few references, and that's it. I would like to show the scraper code which we used. So these are the functions which we um, defined ourselves to get uh, get the train features, test features, and the target variable features. And so yeah, this is the code which we have used in our project. Yeah. All right, that's it then. Thank you so much.